Thank you for joining this Quantum Security Defense webinar, Understanding Quantum Entropy for Blockchain and Cybersecurity. Dr. José Ramón Martínez Saavedra is the VP of Innovation at QSECDEF, where he leads the development of high-performance quantum random number generation, QRNG technologies. A physicist with a PhD in photonics from ICFO and the Universitat Politécnica de Catalunya, José bridges the gap between fundamental quantum mechanics and deployable cryptographic infrastructure. He spearheads QSECDEF's efforts to solve the entropy bottleneck in modern encryption, providing major breakthroughs in randomness metrology and ensuring that the entropy used in blockchain and cryptographic keys is not just fast, but demonstrably unpredictable. David Worrall is an accomplished security professional with over 25 years of leadership and technical expertise spanning classical and post-quantum cryptography. His work encompasses the design, analysis, and deployment of advanced security architectures for government, enterprise, and high-assurance systems. David has contributed to the evolution of modern cryptographic practice through research, participation in standards development, and the authorship of multiple patents addressing next-generation cryptographic mechanisms. Renowned for uniting rigorous theoretical foundations with practical implementation strategies.
So the thing is that compared with other kind of randomness sources, such as, for example, pseudo-random sources, which are the standard ones that you will find on your computers, or true random number generators that are based on, for example, chaotic processes, most of these random sources, if not all of them, are very hard or impossible to validate, in the sense that the entropy that you need to trust somehow that the entropy source is working properly in order to generate the randomness. Quantum random number generation is somehow opposite, and we will discuss that in bigger detail later, in the sense that you don't need to verify, or you don't need, the only thing you need to trust in order to get random number generator here is the laws of quantum physics. So as long as you trust the fact that quantum physics behaves as expected, the randomness that you will get from a quantum random number generator can be certified and validated and trustful without recurring to any other kind of hypothesis on the randomness generation within.
And that really is, as Jose was said, where we see the big shift and how quantum and quantum technologies are starting to move the needle, as people are fond of saying. You know, this is no longer you need to trust it. We're now moving into, people talk about zero trust networks. We talk about don't trust anything. But for the first time ever, we have a technology that will allow you to observe and measure how good your entropy is. And entropy is the real key. So what's been developed, what we develop, and what QRNG developers are saying is, if you have a quantum process and you don't test the output, you verify that the system is working, then you know you have an amount of randomness. Now, obviously, for those of you who want a bit of homework, you can go and have a look at things like Shannon entropy formulations. But within NIST and others, moving away from output testing is saying, really what we need to be doing here is we need to be doing something called a min entropy test. And this says, how much entropy have we got? So everybody here will know something like an AES standard, 256, for instance. But how many may know that AES 256 requires 256 bits of entropy to be fully strong, not 256 bits of a random string? If that random string was made up of 8-bit numbers, just repeated, then there's only 8 bits of entropy in there. So that would not be strong enough. So this is why QRNG and quantum technologies are really being seen as a way forward.
To watch the full expert lecture and to watch over 100 plus lectures on quantum technology, simply search Quantum Security Defense.